Today our lesson's on solving polynomials, and our objective is define solutions of polynomials and characteristics. Okay, so recall, the solutions of a quadratic equation are the x-intercepts of the parabola. So whenever we talk about solutions, remember solutions or roots, these are the same thing as x-intercepts. So if I ever ask you to solve the quadratic equation and you come up with two solutions, both of those solutions are x-intercepts. So this is why we set the quadratic equations such as, so I just gave an example, y equals x squared plus 6x minus 7 equal to 0 when we want to find the solutions or x-intercepts of the equation. Okay, so whenever we have a quadratic equation, such as the one I gave an example to, instead of this y right here, instead of that y, if we made that a 0, then we're actually solving for the x-intercepts of the equation. So graphically, there's two different ways we can look at these x-intercepts, graphically and algebraically. So graphically, it looks like this. So where are the two x-intercepts? Those two are the x-intercepts, right? So wherever it hits the x-axis, if I say find the solutions of this graph, the solutions are -2, 0, and 3, 0. Remember we did that on our last test for factoring. At the very bottom, number 7 and 8, those were, you had to look at a graph and say, find the zeros. Zeros, solutions, x-intercepts, all the same word. It's the same word for a different word for the same thing. All right. So algebraically, it looks like this. You set the quadratic equation equal to 0. So in a different equation, in a different example, y equals x squared minus 7x minus 8. If I told you to find the solutions, you'd plug in a 0 for y, and then you'd draw the x. A times c is -8 and b is -7. And remember, because the x squared, there's a 1 in front, so I'll write a 1 in front of it. Because there's a 1 right here, we can just go straight into x minus 8 and x plus 1. So I'm going to substitute, see how I substituted from here? I'm going to substitute the equation above, the quadratic equation above, I'm going to substitute it with this factored form, and then I'm going to set each of these equal to 0. Remember we did this, so x equals 8 and x equals -1. The reason that x equals 8 and x equals -1, we need to look at each of these individually. So what makes that part 0, the x minus 8? If we plug in an 8, 8 minus 8 is 0, right? What makes this part 0? A -1. So think about it that way. All right, so yeah, both of those are solutions. So 8, 0 and -1, 0. So if we were to graph that, it would look something like this over here, and we'd see the two zeros, 8, 0 and -1, 0, we'd see that on the graph. So those are two different ways to find solutions or zeros. So the solutions of a polynomial are the x-intercepts of the graph visually, which are the values that make up the polynomial when the polynomial equals 0, which is algebraically. So assuming that b is an x-intercept, what does that mean? That means like this. Assume, let's just, I don't know, let's do something like this again. Let's say that this is b. So I don't know, -b, right? It has to be -b because it's let's say -b comma 0. That's what it would have to be, right? And then we could say this part is b comma 0. So we're just not sure what the x-intercept is. But we know the x-intercept, we're just going to call it b for now. It could be anything, it could be any number. Okay, so assuming b is an x-intercept, b is a 0 of the polynomial function. And that's true, right? Didn't we just say that the x-intercepts are zeros of the quadratic equation? So b is a 0 of the polynomial. B, remember b we can substitute with the x-intercept. So the x-intercept is a 0. The x-intercept is also a root of the polynomial function. The x-intercept, B is an x-intercept of the graph. Okay, that totally makes sense because B represents the x-intercept in this case. Remember, the x-intercept can also be called the solution. And x minus b is a linear factor of the polynomial. So x minus b is a linear factor of the polynomial. So if we, for example, and I'm going to draw this out and then I'm going to erase it because I do have stuff below here. But let's say that, let's say this was our polynomial, and let's just say that this is -2, 0, and 2, 0. If I wanted to write a linear factor for this, I would say x minus b. Okay, so b in this case is a -2. So x minus -2 is x plus 2. That's how I'd write the linear factor of this. Okay, and then to write the linear factor of 2, 0, I would write x minus b, and b is +2. So you do see how the signs switch. Okay, so x minus b is a linear factor. So if we have a -2, it's going to be a +2. So we just flip the sign. If it's a +2, the linear factor is going to be x minus 2. Okay? All right. Let me erase this. And then I will move on. So those are the 4 things, assuming b is an x-intercept, that I need you to know. So example. So let's look at this, okay? We'll just call that crazy looking graph f of x. And the first question I have is, what are the zeros of f of x? So of that function, of that red function that you see there, what are the zeros? Well, all of these points, right? -3, 0, 2, and 4. How did I find that? -3, 0, 2, and 4. Do you see all those highlighted points? So all of those hit the x-axis, so all of those are zeros. All right. Those are the x-intercepts. What are the linear factors of f of x? So remember what I just said up here about x minus b is a linear factor? So what are the linear factors? Well, we're going to do the same thing. The first linear factor is x plus 3. Because this is a -3, when we put it as a linear factor, we take the opposite sign. So instead of x minus 3, it's going to be x plus 3. Now this, we could say x minus 0, but what's x minus 0? X minus 0 is just x, so I'm just going to put an x there. X minus 2 is the next one, and then x minus 4. Do you see how those are the 4 linear factors because they correspond with that x equals the x-intercepts? And it makes sense, right? Because if I were to solve this algebraically, wouldn't I set each of these equal to 0? What do I get when I set it equal to 0? -3. Well, isn't this -3 here? And if I set this equal to 0, doesn't x just equal 0? And isn't that here? So do you see what I'm saying? If you think about what we've been going over, it makes sense that you'd have to do the opposite, and that all of those are linear factors. So a key point here is multiplying out the linear factors provides the polynomial equation or function of the graph. So if I were to, which would be a pain, and I'm not going to make you do this, but if you wanted to, let's say you had a ton of time after school today and you really wanted to multiply all this out. If you multiplied all this out, so you'd multiply that, and then you'd have to multiply x plus 3 times x, you'd have to multiply that to this, and you multiply it all out, you would actually get the function that is right here. You'd actually get that function. Okay, so it's pretty cool. So that's just the factors, and I'm not going to make you multiply it out. Okay, those are the linear factors. Okay, so another example. If we look at this cool looking function, let's ask the same 2 questions. Okay, we'll call that f of x again. And the first question, what are the zeros of f of x? Well, the zeros are those 5, right? 1, 2, 3, 4, 5. Yeah, 5 points on that graph, wherever it hits the x-intercept. So if I ask you, what are the zeros? I know I keep repeating myself, but it's really important you know. If I ask you for the zeros, I'm talking about the x-intercepts. So the first one is -4. and then negative 2, and then 1, and then 2, and then 4. So here, all of these are all zeros, okay, and so on. What are the linear factors? Well, I take my x-intercepts, and I write them as x minus b. X minus, and then I do the opposite. So instead of x minus 4, it's x plus 4 for the first linear factor. X plus 2, x minus 1, x minus 2, and x minus 4. Okay? Last thing we're going to talk about today is multiplicity. Multiplicity. So multiplicity refers to the number of times a zero occurs. The number of times a zero occurs. So if we're given a 0 of 5 and a multiplicity of 2, and we're also given a 0 of 1 and a multiplicity of 3, this is how we'd write our linear factors. If I said write out the linear factors, this is what you do. X minus 5, right? And we know that because 0, we're given a 0 of 5. When we're given a 0 of 5, we write out the linear factor as x minus 5. That's what we've been doing. Okay? But it says multiplicity 2. That means we're going to square it. This 2 here tells me that the 5, the 0 of 5, occurs twice. And then, if we want to do a 0 of 1, we do x minus 1, right? So, this one, this 0 of 1, that's how we'd write it down here as x minus 1. And then multiplicity of 3 means to the third power, and that would be your answer. So if we want to go over another example, if we're given a 0 of 6, multiplicity 2, a 0 of negative 1, multiplicity 4, and a 0 of 3, we're going to start with the top. 0 of 6 means x minus 6, and then multiplicity of 2 is squared it. A 0 of negative 1 is x plus 1, remember do the opposite, multiplicity of 4 is to the 4th. And then a 0 of just 3 is just x minus 3. It doesn't have a multiplicity, so it's just x minus 3, and we don't write anything else for the exponent. And that's it.